all accept that aging is inevitable. But not this man. Aubrey de Grey. He's on the hunt for the elixir of life.
People could easily expect to live to 1,000 or a few thousand, maybe longer.
His radical ideas about freezing time are gaining momentum.
It feels like science fiction, but it's actually true. And we're really at the cutting edge. It's a really exciting time in the field right now.
Can human intelligence really conquer our biological clock? I'm about to meet the man convinced it can.
Aubrey has asked me to meet him at his favourite pub in Cambridge.
This is apparently where he does all his thinking. Aubrey?
Oh, hello. Great to meet you.
Oh, lovely to meet you.
Aubrey is a gerontologist. He studies ageing, and he's obsessed with finding a way to cheat old age.
Aubrey, what's so bad about ageing gracefully?
There's no such thing as aging gracefully. I don't meet people who want to get Alzheimer's disease or who want to get cancer or arthritis or any of the other things that afflict the elderly. Aging is bad for you, and we better just actually accept that. As far as I'm concerned, aging is humanity's worst problem by some serious distance.
Now, if you think that's an overstatement, consider this. Worldwide, 150,000 people die each day. 2/3 of them from aging. That means potentially 100,000 people could be saved every day with therapies that combat aging.
We're talking about taking people and putting them back into a state where they don't just function and don't just feel, but they also look just the way they did when they were young adults.
I must admit I was sceptical. I can see how an exponential growth in technology would propel scientific breakthroughs. But aging? It's so complex.
Aging is simply and clearly the accumulation of damage in the body. That's all that aging is. What it's going to take is development of thoroughly comprehensive regenerative medicine for aging. That means medicine which can repair the molecular and cellular damage that accumulates in our bodies throughout life as side effects of our normal metabolic processes.
Aubrey and I spoke for some time. He explained why he thought a war on aging could be won.
The human body can be treated like any simple man-made structure, like a car or an aeroplane or indeed a building for that matter. So here's King's College Chapel. This is the most famous building in Cambridge. It was built by Henry VI back in the 14th century, so that's 700 years ago. And I'm damn certain that Henry VI did not think about making the thing last until the 21st century. But it has lasted because it's been well maintained. That means, replacing tiles that fall off the roof or, cleaning it up every so often, getting rid of damage. And it's exactly the same in principle for a really complicated machine that we didn't actually design, namely the human body.
Aubrey says aging can kill you in 7 ways.
Cross-linking of what's called the extracellular matrix, the lattice of proteins that holds our organs together.
If this happens, tissues will eventually lose their elasticity.
The accumulation of molecular garbage in the spaces between our cells. Most of that garbage is called amyloid.
The accumulation of amyloid occurs in diseases like Alzheimer's.
Number 3 is molecular garbage. Inside the cell doesn't know how to break it down, doesn't know how to excrete it, eventually it gets in the way.
Cholesterol buildup in atherosclerosis is a typical example of this.
The accumulation of mutations in the DNA in this special part of the cell called the mitochondria.
They're responsible for energy production. Aubrey believes gene therapy can overcome this damage.
Having too few cells. So that happens when, in certain tissues, cells die and they are not automatically replaced by the division and differentiation of other cells.
Patients with Parkinson's disease have this problem.
Having too many cells because cells are not dying when they're supposed to.
This can create problems in the immune system.
And then finally, number 7, and that, of course, is cancer. It's caused, of course, predominantly by the accumulation of mutations in the chromosomes.
So theoretically, all those 7 categories are fixable.
I believe that each of those categories is not just theoretically fixable, but actually that we know in a lot of detail how to go about implementing such fixes.
Aubrey is obviously talented, but is he right? His profile among biomedical researchers has been controversial, many saying that his ideas are pseudoscience. But Aubrey has earned his stripes with a PhD in biogerontology at the University of Cambridge. In 2005, Technology Review launched a competition with a $20,000 prize for anyone who could demonstrate Aubrey's theories were unworthy of debate. The prize was never claimed. In the early 1900s, no one would have thought that we could eradicate polio. In the 60s, who would have believed that we could make babies in test tubes? If technology advances in the next 50 years as fast as it has in the last 50, then perhaps it's not that hard to believe that Aubrey could be right. So what do we know about regulating lifespan?
The lifespan of a cell is influenced by small structures at the ends of chromosomes called telomeres. These are like the little plastic tips at the ends of your shoelaces that keep them from fraying. Telomeres have the same purpose. Now, each time a cell replicates, a little bit of telomere is lost until it eventually wears out and the cell dies. So imagine if there was a way we could lengthen telomeres. The cells would become immortal. Would this be the elixir of life?
Incredibly, Nobel laureate Elizabeth Blackburn discovered an enzyme called telomerase. It had the ability to lengthen telomeres and keep cells alive indefinitely. This spawned a frenzied search for a drug that could enhance telomerase activity. One such drug, called TA65, is already in clinical trials. But Professor David Sinclair says there's a catch. Telomerase is the same enzyme that bestows cancer with the ability to resist death.
What I would be worried about would be the long-term use of that molecule because of the known link to cancer. But I think it's going to be important to watch out for that possible side effect.
David has been studying longevity for many years.
So this is where it all began.
With red wine?
Well, not exactly red wine. There's a molecule in here called resveratrol, and so we looked at thousands of different molecules trying to slow down aging in baker's yeast, little yeast cells, and it was resveratrol in red wine that worked the best.
Right.
And with that, we've slowed down aging.
Right, I always knew red wine was good for me, but how much of this would I have to drink to get the benefits of anti-aging?
Well, unfortunately, you need to drink about 200 glasses.
200?
Yeah, that's a little too much. I don't recommend that.
What's a more practical approach?
Well, what we're trying to do is to make molecules that are 100 or 1,000 times more potent or effective than resveratrol. And that way we could have a little pill that we could take just once a day to slow down aging.
Oh, well, cheers to that.
David's designer drug acts on a group of genes that control aging, called sirtuins.
There are 7 of these sirtuin genes, and they seem to do different functions to keep us healthy. So the one that resveratrol targets are called SIRT1. It will protect the chromosomes in the cell, it will burn fat, it will also protect the brain and prevent Alzheimer's and Huntington's disease. There are other sirtuins, and they respond to what we eat and control how energy is stored or burnt. So here what we're seeing, these little green things are the power packs of the cell, the mitochondria. And as we age, they get weaker and weaker.
So are you saying that you have a drug now that can reverse the aging in these cells?
Yes.
That's incredible.
And the proof is in the pudding, or the mouse in this case. The one on the right is treated with David's life-extending drug.
We just sprinkled some in the food, and we found that they lived 25% longer. They had less cancer and less heart disease, less osteoporosis. It was almost as though we had found the fountain of youth. There's a long way to go, and clinical trials are tough for any drug. But I'm really optimistic that it'll happen, certainly within my lifetime and maybe just in the next few years.
And if all these ideas on radical life extension don't happen soon enough, Aubrey at least has a backup plan. This is where Aubrey will come if or when he dies. It's a cryogenic storage facility in Arizona. This is where he'll stay in suspended animation until science comes up with a way to bring him back to life.
At the moment, I'm signed up only to have my head frozen.
Do you not think you're going to need your body when you're reanimated?
The whole point of cryopreserving only one's head is based on the idea that one can simply grow in the laboratory an entire new body without a head and stick it onto the cryopreserved head. So you end up with a perfectly new body, just the same way that one today ends up with a perfectly new heart or a liver or whatever.
That's all very interesting. But if we all stopped dying, I couldn't help wondering what would happen to the population.
One of the worries is that the world will be overrun with old people. If we did stop aging today, population wouldn't grow very much. It's about 1 or 2% per year, which is still something we'd have to contend with. But I think we'll make people healthier for longer. That kind of a world will be a better place to live in. And I also think that people who live in that world will look back today like we look back to the days before antibiotics and say, oh, thank goodness we didn't live then.
We do not know what humanity of the future is going to want to do. If 30 or 50 years from now, people don't have the problems that we thought they might have, but we didn't develop those therapies, so those people have to die anyway after a long period of decrepitude and disease, then they're not going to be terribly happy, are they? That's why we have a moral obligation to develop these technologies as soon as possible.
For all my doubts, I couldn't help thinking that science needs individuals like Aubrey to revitalise our thinking. After all, it's limitless curiosity and imagination that underpins every great discovery.